Okay, the last problem in chapter 3 and the last optimization problem before you guys try and do your review assignment is to a fun problem. It's a really fun problem. It's got a bit of a history and a story to it. A couple years ago, I read this article. I just came upon this article on the internet. The link is above here on in the video, but it's also embedded into your notes if you want to take a break and read up on it. The story went, if I remember correctly, that a number of years ago in the UK there was a countrywide assignment, state exams they're called, and this question was on the grade 12 one, and it challenged a lot of students. It really upset a lot of students and some parents and families, and it again, if the story went correctly, if I remember it correctly, um, the board that administered the exam and created the exam and designed the exam had to account for this question, had some questions, some pretty serious questions and concerns about this particular exam. Okay, the first part of this question, we need to look at the diagram, read it over. Okay, so the crocodile is stalking prey located 20 meters further upstream on the opposite side of the river. Crocodiles, obviously, as you might think, travel at different speeds, whether they're on the land or in the water. And it's trying to find the time taken for the crocodile to reach its prey. It says it can be minimized if it swims to a particular point at P, and that would be represented by X meters upstream on the other side. So this situation right in here is we're saying X. So X could be anywhere from zero, okay, to 20 meters. So somewhere along this 0 to 20 meter length along this opposite stream, the crocodile is going to swim and come out, and that X is going to be measured from the 0 to the point P on here. Okay, the first question. Okay, now take a look at the marks here associated with this. 1, 1, and 8. Okay, so A has two parts to it. I'm asking you, oh, not only that, we should point out that the actual function for T is given in the question. So not only is the diagram given, the function's given. There's not a whole lot of work to do except math. I think the issue with the question was just exactly the wording of the question and what was being asked in some of these questions. So A, part 1, let's do this. Calculate the time taken if the crocodile does not travel on land. So if it does not travel on land, it means it swims, okay, swims the whole time, right? Swims the entire time. Okay, and I think if it swims the entire time, it means that X is 20. So I want to evaluate my function at X is 20. Okay, my function is that'll be 5, and then 36 and 400, 4 times 0. Okay, so there's no amount of time spent on land, it just swims the whole time. And that, I have my calculation to be 104.4. Since that's tenths of a second, it's actually 10.4 seconds. Okay, so when it swims the whole time, it takes 10.44 seconds. The second part of the question, I think I'm going to guess, is that other boundary here. That's when X equals 0. And let's see if that's the case. Calculate the time taken if the crocodile swims the shortest distance. The shortest distance would be right in this area. So yeah, that is X equals 0. And so that's when it swims. What's that situation? Okay, is it swims directly across, and then goes along the entire bank, right? Okay, so that's evaluating T at 0. 5 times 6 is 30, plus 80, 110, or 11 seconds. So it takes the crocodile 11 seconds if it swims directly across and then goes across the bank here. Okay, I'll get on to B in a second. Okay, so we're good with that. Now B, between these two extremes, those are the extreme values we just found, there's one value of x which minimizes the time. So it sounds like we're going to have to minimize the time function. That means the derivative, set it equals 0, solve for x. So let's find this value of x where it comes out down the shoreline, right? And then calculate the actual minimum possible time. Okay, I'm going to go to a different slide. Okay, and write my time function. That's I'm going to rewrite it. That's an exponent. Now I want to take the derivative of it. It's going to be 5 and a half 36 plus x squared to the negative a half. Don't forget to take the derivative of the inside function. That'll be 2x. Okay, and then I want to take the derivative of 20 minus x. Well, that's just 0 minus 1 or that. And if I can clean that up a little bit, my 2's will cancel. So I have 5x over the square root of 36 plus x squared minus 4. Okay, good. Looks good. I have to minimize this, so that effectively is setting it equal to 0 and solving for x. Cross multiply. And then square both sides. A lot of techniques we've already seen. Okay, so square both sides. That means I've got to square this. And I've got to square this. Okay, so when I square 5x, I've got 25x squared. And when I square, I've got 4. And then whatever's underneath the radical expression here, 36 plus x squared. Expand. 16 times 36 is 576. And I've got 16x squared. That equals 25x squared. I'm just going to do this quick. I already have this done on my notes here beside me. Okay, so x equals 8. So the crocodile's got to come out 8 meters down. Oh, on the other. So 8 meters down. So this would be 8. This would be 12. Just a quick calculation. And I'm going to find the time taken then. And I have to put my value of x equals 8 into my time function. And this, remember my function. I do right now. And we've got 5, that's 36 and 64. And 4 times 12. We're going to have 5 times 100. Okay, or 50 plus 48 equals 98. And that's tenths of a second. That's 9.8 seconds. And we just need a calculator. Or sorry, final sentence here. The minimum time taken is 9.8 seconds. And this is found when should say, comes out 8 meters downstream. And comes out at 8 meters downstream. Okay, good. Okay, that's not a hard one, really. If you know your math and you can understand the question, I think, like I said, I think the issue was just actually understanding the question and trying to figure out what was being asked. Anyway, good work. This is a hard one to do virtually and online, and this particular chapter. So do your best with these questions and get onto the review assignment that can be submitted when we're finished chapter 3. Thanks. Bye bye.